Hello, in this short video we're going to talk about how to optimize a logic function with 3 inputs using a 3-input K-map. And as we have seen in the previous video, for 2 inputs we had a K-map with 4 minterms. So basically for 3 inputs we would have 2 to the power of 3 equals 8 minterms. That requires a 3-input K-map with 8 cells as shown on the right hand side here. So now let's look here. We have a system with inputs X, Y, Z and output F, which we don't know what the output is yet. It's a skeleton truth table which shows all the possible combinations of inputs here, and each combination showing the minterm number here. So let's look here. Since we have 3 inputs, 8 cells, we have a K-map here with 8 cells represents a 3-input K-map. Now, there is a governing rule here which I want to bring to your attention in a minute, which says no 2 adjacent cells in a K-map can differ in their input values by more than 1 bit. So in the sense, if I have a cell here with inputs 0, 1, 0, the cell right next to it could have a value something like 0, 1, 1, which shows only the 3rd bit is changing, so there is only 1 bit change allowed. But if there is a cell something like 1, 1, and also a 1, so as you see here, there is 1 bit change and 1 second bit change. So here, when you have neighboring cells changing by 2 bits, this is not allowed, is what we are saying. So how do we fill a 3-input K-map with this, following this rule? Let's look here. The first thing we do is strike a line on the top left corner and write the output name here. And since we have 4 rows, we can represent 2 inputs here. So I'm going to write XY, saying each column represents a different value of XY. And on the left, I'm going to write a Z, which says each row will have a different value of Z. Since there are only 2 rows, for Z, the combinations could be 0 and 1. It's easy. In other words, we are saying the entire first row cell has input Z equals 0, and the entire second row has cells with input Z as 1. Now let's look at XY. So let's start with 0, 0 here, and increment by 1, that becomes 0, 1. As you can see, the difference between these 2 values is only 1 bit, so it is allowed. So let's say if I go with 1, 0. Now if you look into these 2 neighboring cells, there is a difference of 2 bits, which is not allowed. So we cannot do that. So one thing we can do is, if you do 1, 1, the value is changing only by 1 bit, which is only the first bit, which is allowed. So we can do that. And the 4th one is 1, 0. So basically you have a 3-input K-map. Now let's write the minterm numbers here. So the first one is M0 based upon X, Y and Z 0, 0, 0. Now let's look at this cell here. XY is 0, 0, Z is 1. Look for that. 0, 0, 1, which is this. 0, 0, 1, minterm 1, which is minterm 1. Similarly, if I go with this one, XY is 0, 1, Z is 0, so it is, the input combination is 0, 1, 0. 0, 1, 0, minterm 2, write minterm 2. Similarly, if you write it, calculate everything, we end up with a table that looks like this. So that is our simple table here. Now let's look at a simple problem where we are given a system with 3 inputs, 1 output here. And as we have seen in the previous video, I said when we calculate the output of a circuit, we are focused only for the conditions when output is 1. So which is the 2nd row here, the 3rd row, the 5th row and the 7th row here. And let's write the minterm numbers here. Minterm numbers are 1, 2, 4 and 6. So all what we need to do here is write the ones accordingly. Minterm 1 based upon our table as we on the top, M1 is right here, minterm 2 is right here, minterm 4 is right here, minterm 6 is right here. Now, the next thing we have to do is group them. So, as we have said before, the group sizes allowed are 1, 2, 4, 8, and 16. So, identify the largest group here. The largest group here is a group of 2. So, we can group these two here, or we can group these two. So, I'm going to just pick the top right here. So, that is group 1, and I'm going to write it as group 1 for now. The second one is we have a 1 here, and we have one more 1. So, since what horizontal grouping is allowed, I'm going to group these two here and call it group 2. Now, the last one we are left with is a single 1 here, and as you remember, we can group only horizontally or vertically. So we're just going to group this by itself and call this group 3. Now our function f is going to be group 1 plus group 2 plus group 3. Let's start with group 1. Group 1 says, which is the blue one here. Now let's look here. In our group 1, look at the cells, the two cells with the x value. Look, is the x value, what is the x value in this cell? X value is 1, as you see here, and x value is also 1. So is the x value any different in both the cells? No. So we are going to write the x? Yes. The next one, the y value. Is it different or the same? It's different. So we disregard it. So next one, we go with group 2, which is the green one. In group 2, the x value is 0 here, x value is 1 here. It is changing. So disregard x. Now look into y. Y is 1 here, y is 1 here. Is it changing? No. So we write y. The last one is, oh, sorry, my mistake. I talked about x in group 1 and talked about y, but we did not talk about z here. Z is not changing, so it is going to be z bar, and group 2 is going to be y z bar, and the last one, group 3, is going to be just one element. So my x is 0 here, y is 0, and z is f here. Z is 1 here. So our function is going to be just that. In the next video, we're going to talk about 4 input K-maps.